India's Chandrayaan-3 mission achieved a significant milestone by successfully delivering its Vikram lander and Pragyan rover to the lunar surface on August 23. However, 2 weeks later, as the lunar day concluded, the rover's mission faced potential suspension. The Indian Space Research Organisation, ISRO, took a proactive step by placing the Pragyan rover into sleep mode. This decision was prompted by the rover's reliance on solar power, and with the onset of the lunar night, which can see temperatures plummet to a bone-chilling -120 degrees Celsius -184 degrees Fahrenheit, concerns arose about the rover's electronic system's ability to endure such extreme cold. Despite entering sleep mode, there remains a glimmer of hope for Pragyan's reawakening when the lunar night gives way to the return of sunlight on September 22. The rover still boasts a charged battery, and its communication receiver remains operational. If conditions permit, Pragyan could potentially resume its mission. In terms of engineering objectives, Chandrayaan-3 aimed to execute a safe lunar landing and demonstrate the rover's capacity to navigate on the Moon's surface, both of which it successfully achieved. The mission's scientific objectives were to identify water ice and characterize the lunar regolith's composition using specialized instruments such as a spectrometer and spectroscope. These measurements also contribute to our knowledge of lunar impacts and the evolution of the lunar atmosphere. Some initial data from the mission have already been released, including temperature measurements that revealed a notable temperature difference just above and below the lunar surface. Surface temperatures were recorded at 50 degrees Celsius, while a few millimeters below the surface, temperatures dropped to -10 degrees Celsius. This temperature gradient, consistent with findings from other lunar missions, underscores the role of the top layer of lunar regolith as an insulator with limited heat conductivity. Additionally, the mission detected the presence of sulfur at the lunar South Pole, marking the first time it has been identified in this region through in-situ measurements. The complete dataset gathered during the mission will ultimately determine the overall success of its scientific objectives. Initially, Indian scientists will have exclusive access to this data before it becomes accessible to the international scientific community. ISRO has plans for future lunar exploration, including the Lunar Polar Exploration Mission, LUPEX, a joint venture with Japan. LUPEX will involve another lander and rover mission targeting the Moon's South Pole. Notably, the European Space Agency intends to contribute its exospheric mass spectrometer L-band (EMSL) instrument to the LUPEX mission. While Pragyan's fate hinges on its ability to awaken when lunar night passes, ISRO's dedication and achievements in lunar exploration continue to contribute to our understanding of Earth's celestial neighbor. I hope you enjoyed watching this video, and if you are interested in more content like this, please consider subscribing to explore. These videos might catch your interest. I highly suggest that you watch them.